All right, well, let's get started. Welcome to the afternoon session, ladies and gentlemen. This is going to be really good fun. With this, get to have the opportunity to talk to the three of the international keynote speakers about topic of disruption, seeing change coming. We're also joined by a couple of people here from New Zealand. I'll briefly introduce everybody on the panel. Then I'm going to talk for probably about 20 minutes to kick things off and get the juices flowing. I'm not going to talk about power systems. I'm not going to talk about electrical engineering. I want to talk about some stuff that's completely different. I think then we really want interaction from you guys. We want to hear some questions. Today's panel is really the who's who of the Jedi Council of Electrical Engineering on the planet, I would have to say. If you didn't catch the keynotes, I'll give a very brief introduction. Starting down the end, Graham Alt, his students know him as the alternator. Today he's connected in Delta, and we're looking forward to hearing more from you, Graham. Next to Graham is Andrew Renton, who again I'm sure many of you know very well, gets to play with the cool stuff in Transpower, I think is how you would describe what you do. And he's taken some time out from a pretty busy schedule at the moment, raising a puppy, to be with us to talk about the future. Edvina Uzonovic, welcome. Great to have you here. Her children tell her that she doesn't have a funny bone. We all know that's not true, and her brain is immense. So again, looking forward to hearing your perspective. And then Dr. Zia Eamon, who's the chair of the study committee number 4 for Seagrey. Really looking forward to your insights. And of course, Greg Skelton, chief executive of Wellington Electricity, an interesting blend of a local electricity distribution company owned by a global company as well, CKI, so really looking forward to hearing your perspectives. Greg. Okay, so disrupt or be disrupted. The theme of this session is we could never have seen that coming. For those who don't know me, my name's Peter Armstrong. I'm General Manager of MIT and Electronet. I'm not going to talk too much about our company. Most of you will have heard of us, but we are deep in the industry of New Zealand in the power system doing design. And look, over the last couple of years, really taken a special interest in what's changing around us. Late last year, I was fortunate to attend the Singularity Summit in Christchurch, an event hosted by the Singularity University. And many of the themes I'm going to talk about today are taken directly from that. So if you were at that summit, you might recognise some of this. And if you're from Transpower, I know you'll recognise some of it as well, because I've already talked a bit within that business. So this is a real news article. I saw in the press a few weeks ago, Elon Musk launching Neuralink. His plan is to connect brains to computers, which sounds very much like the future, doesn't it? So how on earth did we get here? The answer, I think, lies partly in the mathematics of paper folding. The thing with exponential change is it's very deceptive. So if you think back to how a human mind is programmed, you go back thousands of years, early man or woman is on the savannah chasing an animal. They need to kill it for their dinner. They can predict pretty comfortably that if they chase it and it takes 30 steps, it's going to be at least 30 meters in some direction on the ground, right? Now, that's cool. We're programmed to understand that. But if that animal were to take 30 exponential steps, what on earth does that look like? Exponentials are very, very deceptive. The reality is, in that scenario, that the animal would travel around the earth twice. And the deceptive part is, on the 29th step, it would only be halfway there. Another good example, which some of you will be aware of, is the chess and grain parable. Anyone heard of that? A few people? Yep. Great example of exponentials, and it's a numerate crowd, so you'll pick this up really fast. The way the parable goes is that the inventor of the game of chess went to the emperor, was summoned by the emperor. The emperor loved the game so much, he said, "Come, bring the inventor to me." So the inventor went, and the emperor said to the inventor, "Anything that you can possibly like. This is such a great game. Tell me just whatever you want. I'll give from the whole kingdom. You can have it." So the inventor said, "Oh, it's very simple. So you've played chess. You've seen the board. Take 1 grain of wheat, put it on the first board, and then double it. 2, 4." The emperor quickly agreed, said, "Oh, absolutely fine." But what he didn't realize is that by the 63rd power of 2, we are dealing with more than 9 exagrain of wheat. What does that mean? So I did some pretty preliminary calculations based on the bulk density of wheat, work out how much this was. And last year, global wheat production would have reached about 0.14% of this number. So again, they're deceptive, right? We're going to keep on this theme for a little bit longer. So this guy's co-founder of Intel back in 1967, Gordon Moore. He noticed an interesting trend, which I'm sure you've all heard about. He basically realized by the early 70s that the number of transistors that you can fit per unit area is approximately doubling every 2 years. So he noticed this very early. And there you go, that's data about Moore's law. Many of you will look at those numbers and get a pang of nostalgia between Intel and Motorola chipsets and which one's better and which one's not. But the interesting point is, that's a log linear scale, and you can see that it's an exponential technology. Now, the data goes to 2010, and there's quite a bit of discussion about whether or not Moore's law holds. But as you'll see, I don't think it matters, because the next insight comes from a chap called Ray Kurzweil. Now, has anyone heard of Ray Kurzweil? A little less well known than Gordon Moore. Ray Kurzweil, very interesting guy. He holds about 40 patents. He seemed to invent pretty much everything, optical character recognition. He's also got a bit of reputation of being somewhat of a futurist. He has a go at predicting the future, and he seems to do quite well. He gets it right about 80% of the time. But he noticed that what's more important is the price performance of computing. So this graph is showing us on the y-axis, again, a log scale, the number, millions of instructions per second per $1,000, right? So it's different. It's not the same. But if you look at this relationship, it goes way, way back to basically the first electromechanical relays. So you can see that whilst Moore's law may have some physical limitations, or it may not, the price performance curve goes back a lot further, and it's an exponential. Now, using this relationship, assuming that it continues to hold, I've heard people say things like, right now $1,000 buys computing power equivalent approximately to the neural capacity of a mouse. In a few years' time, human brain, exponential. Kurzweil believes in an event in the future, 2049, called the singularity, where basically, all of the human minds combined, that horsepower is reached through computing. So who knows if that'll happen, but a pretty interesting observation. So that's the first insight, the price performance of computing. While we're on it, and talking about exponentials, this is an interesting one that looks at the power consumption of devices. Over the last few days, there's been some fascinating talks about data, IoT, and so forth. One of the questions that does seem to come up is, how are we going to power these things? You can see a couple of data sources there looking at the power consumption requirements, or watts, again, per millions of instructions per second on the y-axis. When you get down into the microwatt zone, or even potentially picowatts, then you're into potentially harvesting energy from Wi-Fi, backscatter, that kind of thing. So that's quite interesting. So the second insight, just to explain the second insight by way of an example, I'm going to talk a little bit about digital biology. So if you start in roughly 1990, the Human Genome Project was launched. This project took about 11 years. It cost $3 billion. And the idea was to sequence the human genome, right? It was successful. In 2001, the human genome was sequenced, and there set up this industry of sequencing of genomes, which has taken off and continued today. So how much does it cost now, right? So this is real data. If you have a look, soon after the first genome was sequenced, the price was sitting about $100 million. 10 years later, several orders of magnitude have been achieved. If you actually have a look in real terms about what's happening now, what have we got? $3 billion initially. Price of a used car, about $1,000, less than that now. Cost of flushing the toilet in the future? Don't know. While we're talking about this soon-to-be interconnected device, it will very likely know more about you in the future than your doctor will. This is another cool one, sticking with health for a bit. So, Star Trek fans, there's usually at least one. Yeah, two. Okay, cool. Thanks for admitting it. Me too. So the device called in Star Trek, they have this device called a tricorder. Pretty clever device that can pick up basically health conditions and give diagnoses and courses of action and so forth. So about 10, 15 years ago, a foundation was launched called the X Prize Foundation by a bloke called Peter Diamandis. And the idea was to get people to space and back. So they had the SpaceX prize, and you get there and back, and you win a $10 million prize. It was won by Scale Composites, Burt Rutan, which was ultimately bought by Virgin Galactic. They cost them well more than $10 million, but they did it anyway. X Prize Foundation has persisted, and recently they've had a project called the Tricorder Challenge. So the idea is to make a device capable of detecting 13 conditions, not just high temperature, but actually quite complicated medical conditions at a level better than a doctor. That prize was just won about a month ago, and so this is real. So it's in the process of being commercialised, a tricorder. While we're talking about exponentials, this one's quite cool. This is EIA work, just looking at solar price performance. You can see, so effectively the units on the y-axis, millions of BTUs. It's effectively another form of joule. I can't remember the conversion rate. Someone will be able to fact check it and tell us in the audience. But you can see solar coming in here at the end. It doesn't even feature until the last few years. And so solar is very much on an exponential price path, whether you like it or not. It's happening. And it's interesting to look at this. I mean, in the era of Trump. It's hard to say what's happened. It's actually, in my opinion, relatively easy to say what's going to happen, but that's the market cap of America's 4 biggest coal producers since 2011. It's probably gone up a bit with the announcements around coal, but it's hard to ignore that volume of change. So the third insight is around convergence. So you get the real action with these exponential technologies when they start to converge. So I'll give you an example. So, I mean, we've all heard of Elon Musk, right? I mean, he's a pretty well-known name now. This guy's investing in all kinds of things. As you know, Neuralink, he's building tunnels. He's got cars, he's got batteries, he's got Solar City. So what's going on here? The real magic starts to happen when you see convergence of Silicon Valley. I'll come back to what I mean by that in a minute. Battery storage, solar photovoltaics, artificial intelligence, microgrids, IoT. I'll give you an example. What do I mean by Silicon Valley? I mean, that article, you probably can't read it in the top left, talks about a firmware upgrade in 2015 for the first generations of the Tesla motor car. These cars were in their garages connected to Wi-Fi at the time. They got a firmware upgrade, they got autonomous driving capability. So the car was shipped with the sensors, a firmware upgrade, there you go. And there was a great presentation earlier about batteries, looking at the autonomy levels, and Tesla's going for that third level. But really interesting, right? So this is a totally different way of thinking about a car. 20 odd moving parts compared to 2,000. It's a piece of technology. So convergence. I'm just going to park those insights for a second and talk a little bit about one particular area which I think is interesting, and it's been mentioned a number of times over the last few days. I quite like this Gartner approach to hype. It's very easy to get wrapped up in technology and change, and it's a bit like the Y2K, isn't it? A lot of heat, and is this real? What's actually going on? So I like looking at this curve. It's quite useful. On the left-hand side, the innovation trigger, the peak of inflated expectations, and things come off that peak into the trough of disillusionment before finally making it out to the slope of enlightenment and onwards. But I'm going to zero in on one particular technology, which is machine learning. So again, telling some stories today about things that are happening around us to promote some discussion with the panel shortly. In game theory, they use this figure called the Shannon number. So anyone heard of the Shannon number? There must be some mathematicians in the room. No? Okay, well that's good. I won't have to pretend like I know a lot about it. Basically, it condenses down to the fact that you look at the number of permutations that are possible within a game environment. It's more like all numbers or indices, it's more complicated than that. But generally, you look at, say, how complex is a game. So over on the left-hand side, you'll see a picture of Kasparov being beaten by IBM's Deep Blue back in 1997. So this is, how did we get to that? I'll come back, just park that thought for a second. Little bit of history on machine learning. So machine learning invented by an electrical engineer back in the 1960s at MIT. He wrote an algorithm deterministically to play the game of checkers, right? And it was hopeless. It was crap. It was very easy to beat. Didn't have any strategy. Didn't learn anything. So he changed approach and said, "Okay, what I'm going to do is I'm going to use some statistical processes and feed an algorithm actual games and get the game to learn." And so he did that, and it worked. The checkers capability got to sort of amateur level, So it could play a fair game, it could think up some pretty good strategy. Fast forward to 1997, Kasparov gets beaten by IBM's Deep Blue. Now, chess has a Shannon number of about 10 to the 120. So, again, it's more complicated than this, but approximately 10 to 120 permutations. A lot of permutations. Kasparov got beaten. 2011, IBM's Watson it gets taught how to play Jeopardy, actually. It gets fed Wikipedia, a whole lot of information, facts, media, and it starts playing with people, and it's not that great initially. It's easy to beat. But they keep playing, keep feeding information. Eventually it goes up against the world champions, 2011, and smashes them. Fast forward to 2016, which is last year, Google's DeepMind beats Lee Sedol at Go. What's Go? Anyone play Go? Cool game, really cool game, really simple. This is Go. So basically the idea, it's 2,500 years old at least, roots in China. The idea, two different colors on a grid, you've just got to surround your opponent. It's almost as simple as that. And so there's an example of a game and play. You can see some changes in the board between the two moves. So Go has a Shannon number of 10 to the 360, which coincidentally is the same number of atoms in the known universe. Now, last year, Google's DeepMind beat Lee Sedol, and that happened in South Korea, and about a month later, South Korea announced something like $3 billion in investment in machine learning. And it's getting used, so many of you will know this, but these computers, these algorithms, these technologies are being made available. I think I heard yesterday that GE, for instance, is using Watson, and certainly DeepMind is being used in health applications. Pretty interesting, eh? So I like to look at exponential technology and disruptive technologies in terms of the 6 Ds. And again, these insights came to me initially through interaction with the Singularity guys. The way they describe it is, for something to be exponential, for a technology to experience exponential change, it needs to be digitized. You cannot get exponential growth on a paper-based system, an analog system. They're deceptive. The initial metaphor of the person chasing an animal, you sit here and look at how many of us have looked at curves. They start to make an inflection like this, and if I had $1 for every projection curve I'd seen that shows a linear line coming off the end of this, or a series of them, I wouldn't be here. I'd be in the Bahamas or somewhere. But actually, when you look at a exponential relationship, there's no way that you could see it. So they are very deceptive. And by that nature, also very disruptive. Exponential things allow technology to effectively become demonetized. What does that mean? Demonetized. Think about exponential price performance. If the same performance today is half the cost next year, and then half again, eventually the value almost becomes free, right? Almost becomes free. Now, not every technology follows a price performance curve like that. The trick is finding the ones that are exponential, and the thing that I'm really keen to discuss is, which of these things are going to affect us in our industry. dematerialized. So, again, where's my cell phone? Who's got a drawer at home? I know I do. It's got a GPS in it. It's got a TomTom. It's got probably a torch. These things that are no use to me anymore. I mean, I do everything comes to you on your telephone. So they've been dematerialized, haven't they? And then democratized. So I think the optimism around all this technological change is to say, well, if say photovoltaics does continue on an exponential price performance, it becomes very cheap. It enables energy. The third world can use energy. It can desalinate water. It can grow crops. It can do this. It can do that. Right? So 7 Ds, 6 Ds. All right. So just before we get into the panel discussion, I've got one final story to tell. Again, it's not related to the power industry directly, but hopefully we'll look at it and reflect and think of what does this mean for us. It starts, again, back in the past with the spice trade, an ancient trade that's been around for, well, millennia, really. Initially North Africa, up into Asia, and then subsequently the Silk Road established to take spices from the east to the west. Around the 1600s, Christopher Columbus got on a boat and got across to America. So the sea routes opened up, and fantastic story. We've all probably heard about it. The question is, what disrupted the spice trade? So on the east coast of America, in the late 1700s, a entrepreneur called Frederick Tudor decided that he was going to get a ship, and he was going to modify it. So he heavily insulated the walls of the ship. He used straw and hay bales and whatever he could get his hands on, and he got busy. He decided that he was going to cut ice out of Lake Michigan, I think, initially, and he was going to ship it to India. So there they go, cutting the ice out of the ground and send it off to India. So he tried this. The first ship sailed, the ice melted, lost quite a bit of money, and came back and tried again, right? So cut more ice out, modified the design of the ship a little bit, put the ice in, got on the boat, off they went. Ice melted again. So twice he's failed. He goes back home. He gets put in debtor's prison. You can't sort of go bung back then and just, file bankruptcy. They throw you in jail. He was fortunate though. He had family with reasonable means, I guess. He convinced them to bailed him out, got him going. He did it again, right? Third time. He got a third of the ice to India. He sold the ice. He made an absolute fortune, and he initiated the natural ice trade. So the point is, the spice trade wasn't actually about the flavour and the spices, right? It was about food preservation. Now we all know that the spices don't actually preserve the food, but back then they didn't care. They thought that it did. And so when the Tudor opened up this market of natural ice, all of a sudden people could take the ice and put it into these ice houses, and they could keep produce fresh for longer. And then eventually the ice houses were supplemented with ice boxes, so you get a block of ice delivered to your door like the milkmen used to do, and so you keep food. And then eventually the fridge, right? And so what disrupts the fridge? Any ideas? Come back to it. There's no right answer. It hasn't been disrupted yet. The other, I think that you probably get the point now, but I mean the interesting thing to reflect on is Nokia was an extremely innovative company. I mean, I like to talk about Nokia to differentiate between, say, innovation and disruption. Nokia founded in, I think, 1850 or something, a pulp and paper town, innovated continuously for 150 years, and eventually got disrupted by the music industry, right? So their innovation was great, but perhaps the awareness around what might disrupt us, or what industry am I in, or what do my customers want, I'm not sure. So these are three questions that I think I'm going to sort of put out there and perhaps start with the panel on. And they come again from off the back of the story and the conversation about, what industry are we really in? So the first question, what industry am I really in? And what industry will my disruption come from? And then of course you can say, well, what jobs, will we always be better at than machines? And there's plenty of examples. You've all seen the media, the hype, I guess, about the potential for machines to supplant roles in businesses. So these are the questions. So what industry are we really in? Who wants to go first?
Well, I could answer your first question about what disrupts the fridge. It's teenagers. They do it both ways. They take stuff out. And then if they ever put something in, it's really a science experiment, which you can't eat because it turns to penicillin. Industry, I'm in the industry of satisfying my customers' emotional needs. That's my industry.
Great.
I reckon we're in a trucking business. We're a bunch of courier, Transpower. Greg, we're a courier company. We pick up energy and we take it from one spot to another. And eventually, with all these people who've got solar panels on the roof, we're going to pick it up from their house and we're going to take it somewhere else. Just like DHL or any other service that comes to your house and delivers groceries or takes your rubbish away or anything like that. So I don't think we're a power company. I think we're a trucking courier company.
What can you do about my teenagers, though?
Put them in a box, I'll take them away.
It's a good point, Andrew. I mean, and I think, Greg, you made the point to me a little while ago about, I think it was a Tony Seba metaphor showing, many of you will have seen this, right? Is it Fifth Avenue in New York, Easter 1900? I don't have the photo, but the horse and cart up and down the street, like 13 years later, the same time of the year, photo taken, not a horse in sight, full of cars. But you made the point. Well, I mean, I'll let you speak to it. But what's important is the road, right?
Yeah, it's interesting, futurists, and you've got to be very careful as to listen to them very carefully and help them actually get beyond what they think is an exponential. Peter's excluded from this, of course. And Tony talked very carefully about disruption in transport, where horse and carts were superseded by cars. But the point he could have made was he was speaking to a room full of people that were in a electricity or infrastructure industry. So the infrastructure of the road in Fifth Avenue is still there today. It wasn't disrupted. All that happened is what went across it is different. So it's a bit like what Andrew's described in his trucking business is we're just going to be shifting energy. And like the ice, we've shifted it one direction only in previous years, but now we're going to be starting to shift different forms of energy in a whole lot of directions as we don't talk about networks anymore, we just talk about platforms and how we enable those to work better for our customers on their emotional needs.
Great. I mean, just on the topic of platforms, I mean, Graham, you've had some really interesting experience sort of bridging the gap, I think, between, utility, the cloud, ICT, taking Petri dish innovation and commercialising it. I mean, what are your thoughts on that?
Yeah, I mean, I think platform's a great term, and especially for the infrastructure in the electricity sector. It is a platform. It's a platform that either ships or stores or produces or manages the delivery of. And I think what we've done, and we're just one small player, is look at the control software data platforms to allow that to happen more efficiently or more reliably or more optimally, I suppose you could say. I think going back to question one, I think unequivocally we're all still in an energy industry, and the energy, the forms of it in terms of where it's produced, if there's a primary fuel behind that or not, how it's shipped, which vector it's in as it's shipped, how it can be stored, all of those are variables we've all got to now juggle and play with, but it's still about the delivery of energy with certain characteristics and parameters to customers that want to use that to service their own activities. So I think energy certainly. I think the other perspective we would have on that is the data, IT, software side of that is an ever increasingly big component of the energy sector. And I think we had the discussion yesterday, Edwina had the question, in the keynote day on Wednesday, about skills and power engineering. I think power engineering is a fundamental, but the breadth of additional parts of this sector now, whether it's from IT or data sciences or whatever, those are growing wider and wider, and I think as, our engineers, we have to embrace all those other guys coming into the room with us. I'm not a software engineer, but most of my colleagues are, so I've got that as a daily challenge.
It's an interesting question. I mean, just following on from that, Graham, do we have? I mean, I've made an observation over the last few years that fundamentally the core engineering syllabus that we teach is certainly the one that I learned was effectively 100 years old. I mean, it's got plugins around 2017 if you're graduating now. But do we need to go back and look at that curriculum?
Yeah, it's a massive topic. I mean, I think, hats off to Canterbury, Auckland, and universities in Wellington and others. Same where I came from, Strathboy, I'm guessing the same at Rena as well, Worcester in the US. I think the curriculum has probably evolved quite nicely, but I think that there comes times when a bit of a fundamental look at that comes along. And I suppose, as an ex-electrical engineering professor, you'd be looking at the more generalist courses, looking down your nose at that slightly. Well, that's a bit easier. It's a bit of geology, it's a bit of civil, it's a bit of IT, it's a bit of environmental. In actual fact, I think a generalist undergraduate curriculum is probably right, and then specialise into masters in research, and then get go for the deep skills that are really going to allow innovation and push the bounds at that advanced level of study. That's a personal view.
It's a good comment. I mean, what are your thoughts on this, Edwina? Obviously, I know something that you're very well researched on the topic.
I would say that I'm very well researched, but I don't think that fundamentals are going to change. We still need those fundamentals in engineering. Those would be math and science, and we definitely need them. And when you look at the undergrads, we're going to enlarge the traditional power system teaching with communications and IT. That has to be done that way. So when you look at it, 4 years, that is going to be really enough to cover fundamentals of everything. And then later on, you will have to pick and specialize in particular area, take basically either a master's degree or continuous education. I think that the only thing that I can basically say about education is that gone are the days that you could just finish your degree and start working and end up in the same position and with the same skills that you started with. I think that all of us will have to change and will have to learn to adapt and to accept new technologies, and then we can say that we are successful. But fundamentals are going to stay the same, I believe.
Yeah. Well, look, it's a great comment. I mean, I recently heard somebody say that perhaps the most valuable skill that we need to consider in the future is actually looking at our ability to, well, he said unlearn, but I wonder if it's actually relearn, right? To challenge some of the fundamentals that we've said it's always been like this, so we continue to do it this way. Yeah. Have you got any reflections on that, Zia?
On the education side?
Yeah.
I think, the fundamentals probably are going to stay the same, but there is a trend that we will move away from the classical sequence network analysis into more deeper, especially with faster computers and software. So there is a need, you can see certainly in the dynamics area, for example, to combine various platforms together so that you reach an answer much, much quicker rather than discrete solutions in different platforms. It's coming, and there are research taking place in those areas. So I believe in the near future, none of us will be probably doing load flow or short circuit analysis based on sequence networks anymore.
Wow.
It is going that way.
Excellent. Yeah, Graham.
I think just building on what Edwina and Zia said, I think that the description of fundamentals is right, and I suppose in my ideal generalist first degree, some core fundamentals are good in electrical engineering. Once you've got Ohm's law and Kirchhoff's law, a few numerical methods and extra concepts inside, you can just about solve anything. I think it's the breadth of the set of fundamentals. So is it fundamentals in IT, Is it fundamentals in electrochemistry for storage? So which set of fundamentals are going to be the core part of the energy or the electricity sector in the future? I think it's going to be a bigger and wider set of fundamentals. So we have to think about who's going to, or which of us want or have an appetite for trying to get their head around a width of those new fundamentals, and at least know enough about them that we can steer and guide and architect the future system.
Okay. Well, I mean, should we have a crack at that second question then? I mean, where is our industry? Where's our disruption going to come from, or which industry is it going to come from? And one of the tools I personally quite like from motivational psychology is the concept of the Johari window, which is effectively a 4-quadrant window that says, this is what I know, this is what I know I don't know that I know, and then there's the things that I just don't know that I don't know this, right? So they're blind spots. So I think if you're facing that question around where's disruption going to come from, if we knew, if you do know, tell us, what are we doing about it? So what are your thoughts, guys? I mean, have we got blind spots, or what can we be doing to make sure that we're right on top of this question? I mean, you're welcome to directly answer it if you think you can.
Shall I answer? Shall I start then?
Please do, yeah.
I think we already had a disruption with wind energy coming onto the system about 15 years ago. I was working in the planning department of the UK utility, transmission utility, when we had the first application to connect to the system, an offshore wind farm, about 500 megawatts. And at that point I was working in the power quality area. And we sort of sat down and thought, do we actually need to do anything here? And it just caught us by surprise. We really did not know the answer at that point in time. And we later sort of went into that exponential learning curve and realized that we had to do some analysis and specify some limitations to this connection. Otherwise, it's going to cause a lot of resonances because of the long cable they're introducing, because of the harmonics they were going to push into the system, etc. But the fundamental was that it did catch us by surprise. And I think we are a bit better prepared now for the solar disruption, possibly. But the storage is lurking behind, and we really do not know what to do with it in terms of its dynamic response onto the system, what will happen, how do we analyze the various parts and components of it. And then the introduction of the electric vehicles. I mean, taking charge from the system is one thing, but then pushing power back onto the system is another thing. How do we deal with it? We are talking about cars in the millions and each one having its own controller. How do these controllers interact with each other? Who is going to make sure they don't actually interact in the negative way? Is there going to be a master key holder somewhere? Is that going to be the utility? Or who will take that role? So there's a lot of work there, and certainly I think we will all be not out of jobs soon with that.
I'm not so worried about the technical stuff because we're all smart and we can sort all that stuff out. That's our job, right? That's what we do, and we can learn those types of things from history. That's quite straightforward, he says flippantly. The bit that worries me is where it's coming from. And the piece we don't do well is the social interaction, right? So how many social scientists are employed in our businesses? Because you can go and buy a solar panel, and you can go and buy a car, and you can go and buy a battery. There was a whole trade show out there. You could have gone and done it. It's the driver, the why, and it's got nothing to do with engineering. It's got everything to do with the emotional response of people to certain issues. Whether or not you believe in those issues or not is completely immaterial. What it is the critical mass of people who do believe and just how quickly they'll move. So when all those electric cars turn up, can we do the job we're supposed to do? When they slap all their solar panels on the roof, can we do what they're supposed to do? And I don't really care, we'll solve the technical problem, but it's the emotional human element that will do it. I know in July that the Minister of Energy and the Minister for the Environment are sitting down with a bunch of industry to work out how quick are they going to think about doing anything in the carbon environment. Now, if they walk out of there at the end of the day and say, right, by 2013, we want to be like, oh, sorry, not 2013, 2030, we want to be just like India, and there's not going to be a internal combustion car sold, not saying it is, But imagine what that would do. Suddenly, we would have to solve those problems, but we would have to solve those problems in under 10 years. And we would do it, right? So it's not the engineering that worries me, it's the social part.
Yeah, it's a great point, and I mean, ultimately, I think time and time again we've seen evidence that the customer, if industries are not proactive about change, then the customer will ultimately make decisions that we'll have to react to, right? I think that sort of leads naturally into a question about our assumptions around our relationships with our customers. I think they're all different depending on what part of the industry we work in. But what is a future relationship with say Transpower or an EDB look like? Perhaps start with you, Greg. What are your thoughts? I mean, how do your customers or the end user customers fit into your dialogue these days and in the future?
Yeah, look, I think it's an area that we have to be careful with industry structure, on the fact that we very quickly sort of change our position depending on what's going wrong. If the lights are on, then the customers are the retailers. If the lights go off, then suddenly they're ours. So there's kind of a management around that we need to do as well. And I think that's probably what's going to start to open up those relationships to be a lot wider than they've been before. And it's really going to be around what sort of service offerings people are going to want. We're already disrupted by electric vehicles on the fact that we would have tried to control those through some of our existing control systems and then wire them up like an electric hot water cylinder, and then we'd have ways of managing them to only come on when we had space or not come on if they didn't. But that's all going to, well, it's gone. We haven't done that. But what we haven't done is actually thought about the computational power of the vehicle themselves, and that all the brains are actually sitting in the product, not sitting across on the EDB side. So all you really need to do is start to provide the signals for those vehicles to then decide what they need to do when they need to charge, and then maybe find a way of actually having an override if they try and eat too much at the wrong time. So those sorts of things we're exercising our mind. As far as customer relationships go, I think one of our big disruptors could be what's happening around the world at the moment around populism and the ever widening gap between the entitled and the unentitled. We're quite lucky that we all live, work and breathe in an industry that's very privileged, and we end up having a lot of things that are very we're very privileged to have. I think what we're not seeing though is the gap between the informed economy and the uninformed economy, and I think the depth that people can actually get information from their smart devices, which may be targeted to a certain way of thinking. I think we've seen that around the world, and Edwina can talk about that much more than I can, and so can Graham. But if you look at how much distrust there is between informed and uninformed in our communities, and privileged and unprivileged, you're starting to see those numbers widen, and as they widen, as you get near an election, you're going to start to see things happen that we weren't really expecting. I wasn't expecting Winston Peters to have the influence he's going to have in this next election. For my guests, Winston Peters is a politician. If you're on the Titanic and you had the choice between a life jacket or Winston Peters, you'd grab Winston Peters. He's got such a survival rate. He's always there, so he just keeps popping up. But those influences around being able to be targeting popular thinking around gold card, around iwi needs, around unemployment. He's won Northland in 2015. Only 30% of Northland have a wage and salary. So he's one of the people that is going to drive that through. We've seen what's happening with other countries around the world. So I think we've got to be very careful that we step outside our bubble occasionally that industry provides us, and we're very lucky to have, and actually start to think about our customers who may not be thinking solar panels, may not be thinking electric vehicles, may be thinking that the wage and salary they used to have that allowed them a reasonable existence is now further away from actually buying just the basic necessities. So I think that's what we've got to do around some of our services to our customers, is try and work out how we actually bring everyone back up to an even playing field so they can enjoy the quality of life in their later lives that their parents might have enjoyed that we may not be giving them right now.
Yeah, it's a great point, Greg. I mean, and look, it makes straight away that makes me think about when you talk about the rise of popularism and that widening gap. and also the influence of the media. I mean, we've seen these horrible phrases like alternative facts and fake news and this kind of stuff, and people will tend to, they don't really care how our industry works, do they? I mean, they don't care. They care what puts heat into their house at the end of the day. So, yeah, no, I think really, really, really good reflection. What are your thoughts, Andrew, in terms of the relationship with customer?
That's obviously I'll do anything Greg wants for a price. This is an interesting space to be in right now, right? And it's going to be really good. If you listen to the battery guys who are out there in lots of journal articles, batteries can do so many things. They can solve grid issues, and they can solve distribution issues, and put money in the householder and all that. Just picking up on Graham's point, you've got all these extra things that go with it. So if I can just talk about a little case example, up in the upper North Island around Auckland, we're going to be a few hundred megavars short in 2025 or so. And there's many ways you could solve it. We could whip out and buy a StatCom, $40 million, one install, job done, brilliant. And then there's going to be somebody who's going to rock in and say, possibly from the less informed, will turn around and say, well, you could use your battery. Why don't you pay everybody in Auckland to use their battery? Use the inverter on the battery. So you quietly do the math. I need to talk to 40,000 batteries to do the same job. And if I've just spent $40 million on my StatCom, that gives me a capital recovery of $3.6 million a year. 3.6 million a year divided by 40,000 batteries. That's about 50 cents for every time I want to use it. Right? So over a year, that might be $100. Now, I'm not sure you're going to race out and put a 10 kilowatt battery in your house, so Transpower can pay you $100. But let's pretend that that was the tipping point, right? You're putting it in for backup power, and you're putting it in to lower your power bill, and you get the idea that Transpower could pay you an extra $100. My question is, how do I pay them $100? Because I don't see the end consumer at the end, right? And the existing market's transaction burden for me to actually pay you all $100 means that everybody else clips the ticket and $1 falls out the end for them, right? So we'll still never get hold of that 100. So my question to everybody else in the audience is, what do we need to change in the marketplace? What type of magic box has to sit there and compute the whole time in the customer's premises? What's the current price? Oh, look, Transpower's going to pay me $10 if I do something. Greg's got a bit of a demand constraint. He's getting an extra $2 from Greg. I don't know how we do that now, but how do we do that?
Graham, I can see you've got something, partial response to that, I'm sure.
Yes, it's an absolutely great example, and in our work in the UK and also Northeast US, that exact same problem or challenge or possibility comes up. And I suppose if the last 2 decades since privatisation of the electricity sector has been dictated in part by efficiency through procurement process, competitive procurement process, I think what seems to be emerging now, and there's the examples I'm citing in the UK and US, are going a step further than that and throwing out the challenge into the open environment. So you, rather than say, okay, well, reasoning through 200 megavars, the StatCom, but you throw it out and say, well, who can provide 200 megavars? And the possibilities coming from a marketplace who are data-enabled, massively efficient, probably got their hands on the disruptive exponential technologies more than we do, are amazing. My example of that, which my mind boggles every time I think of this, my son, some of you saw him at the dinner last night, started creating YouTube videos of him playing computer games, uploading it, and then YouTube have their click ads revenue. So when he gets a number of viewers, they'll start paying him for putting content that they can advertise. So that's all worth a fraction of a cent every time, but the sheer volume of, when you're thinking about 40,000 people doing something and who's going to coordinate that, it's all becoming very possible now. So who knows? Those guys in the batteries may be providing for you, but through a third-party intermediary and something.
And that's the point. It's like we don't know. So we have to be open to the fact that is a real possibility, and we don't have the answer now. But we have to imagine that could be here in 5 or 10 or 20 years' time, and therefore put all of our infrastructure So our physical infrastructure, our learning infrastructure, our people infrastructure, the rules and regulations that we want to operate the market under, that all has to enable those sorts of transactions to occur.
And the two examples, incidentally, on throwing things out to the open marketplace, where it's the City of London and then City of New York, so big demand-led constraint problems. In New York, the solution would have been a $2 billion US dollars investment program in refurbing, upgrading substations. They've thrown that out to the demand response industry and said, right, we are not going to build this. Who can come forward with some solutions? And then everybody from battery providers, industrial and commercial demand response aggregators, electric vehicle aggregators, all of them are now coming forward saying we'll provide a bit of the solution. So.
I'm just going to bring Edwina and Zia in as well. I know both presentations earlier in the week covering much of the stuff about big data, 10 terabytes a month of synchrophasor data in America. What are your thoughts, Edwina?
Well, we have so many possibilities to change our industry, but the thing is, change is not coming that easily because time constant of implementing new technologies and changing the way we do the business is directly proportional to our sense of risk adverse, right? We are really risk adverse, and simply because of the fact that we are taken as a granted in a way that we provided electricity rather securely for 100 years, so that is expected from us. And I don't see we're gonna see the change, big change, unless we change and we move our passive consumer to rather prosumer. The moment they actually start getting active in our industry and realizing what our industry is and what kind of challenges are meeting, then we can actually see the real changes happening. Other than that, I think that we're going to continue being risk adverse simply because everybody expects from us secure and 24/7 supply of electricity.
Do we think that that expectation around security and supply? I mean, is that something that needs to be priced back to prosumers in a different way or communicated in a different way, say?
That is something that actually we started talking about in the US, and it's going to be actually quite a big question in the future. It's basically social rate, how much you're going to pay for a kilowatt hour. And some people have deep pockets and they can actually afford that to have 24/7, while other people actually obviously pay much less and will not have 24/7. That is not something that I would like to see. But again, it is going to be changed in the future, I suppose.
Yeah. Have you got any comments to add to that, Zia?
Last year I was in a similar panel in IET, one of the conferences, and one of the panel speakers made a comment about these electric vehicles and batteries, and his prediction was that by 2030 we will not buy electric vehicles, but we will buy batteries, and the car will come free of charge as a freebie next to the battery. Whether that will happen or not, I don't know. But going back to the point about working all these within the electricity sector, I think I'm going back to the presentation I made yesterday, the two models. Perhaps all of them will be possible in the small-scale concentrated form. But when you look at the bulk transmission system, probably that is not there yet as we speak. That will take some time. When you look at the big transmission systems, the ones in Brazil, India, China, it's getting there, but really only just a fraction yet. Right. Compared to, I don't know, say Denmark, for example, where it's fully renewable sources. So we need to take the two completely separately, really, the two systems there. And in terms of your data, yes, there is a huge amount of PMUs, for example, being introduced onto the systems, millions of terabytes of data. We still don't know what to do with the data, really. We are not equipped yet to that level. I was just mentioning to Edwina before we started, I have a technical brochure to review before publication, and it's on the PMU use. I don't know what to make of it, to be honest. So we will get there, but it will take some time. I think the first thing we need to do, we need to change our behavior, as Edwina was saying.
It's as you've seen from the introductory talk, certainly a special interest I have is around artificial intelligence and machine learning. And I guess I'm just interested, thinking about the PMU, thinking about the cornucopia of smart meter data that exists and is only going to get richer with time. What's it going to take for us to set these algorithms free? Maybe those are the wrong words, but apply these algorithms to add more value than we already add. I mean, I think we had an interesting conversation before about skills profile. Do we need to be collaborating with the ICT space more to get this value?
Yeah, definitely. Again, going my utility days, we used to joke with the planning engineers, and I apologize to those who are working in the planning area, whereby they had about 90 days, and still applicable in UK at transmission level. When you apply to connect to the system, you have to go back with a bilateral agreement within 90 days. And to do that, you had to run all the data through, you had to run all your voltage analysis, your terminal analysis, etc. And that took time. And me and my colleagues sitting in the modeling area, a bit more sort of sophisticated and esoteric calculations, we used to joke and said, in 20 years' time, probably these guys won't function at all. There will be an online system there, somebody filling in the data, hitting a button to apply to connect to the system. And it was just a joke. and today, in my day-to-day job, we are doing some work for PJM in US, and I can see actually the parallel. It's happening. The data is being filled online, and it's just a background calculation that's not happening, and it's only a matter of time that will happen. And probably when you hit the button there, somebody behind the scenes automatically will run some load flow studies, some short circuit studies, some basic stability studies, and come up with a bilateral agreement from the printer.
Yeah, I mean, as a manager of a consulting business, the thought of that is terrifying in a way, because that's what we do, right?
No, I think you're still needed, but you will be needed in much more complicated areas.
It's an interesting discussion. I recently, just to follow on from your points there, I recently met with an artificial intelligence investor in Christchurch, and to set up the meeting, he sent me an email and said, "Oh, Peter, great, we'll have coffee next week. Clara, can you please set up a meeting with Peter and I for next week?" And so Clara comes back to me and says, "Hi Peter, what's your diary look like?" So we set up a meeting, and then I realise I've double booked myself, and so I go back and say, "Oh Clara, sorry, I've double booked myself." And okay, no problem. She fixes it up, and we go to the meeting. But before we go to the meeting, I just noticed that Clara's email is clara@claralabs.com. So you can probably see where this is going. I went to claralabs.com. It's an artificial intelligence tool that organises this guy's diary for him. So effectively, and so I had an interesting conversation with one of the administrators in our work about this, and they said, "Oh my goodness, that's a part of my job." But I think the question, or the point that I took from that is actually that's a low-value activity that can be automated, freeing time up to do higher value things, right? So I think that's the interesting point, isn't it?
I have another example, if you have time.
Of course.
When I first went, I'm originally from Greece. When I first went to UK to study to do a master's degree, and then I stayed during a PhD degree there, I used to watch the 4 national channels, and ITV, Graham would know. Just before the commercials, a little square came up on the TV's right-hand or left-hand upper square there, like a barcode. And soon we realized it was about that after a minute the adverts are going to hit the screen. And everybody is sort of wondering, okay, they're just telling us that the adverts are coming, and nobody made any note of it. And then when I finished my degree and I started working for the utility, I had a chance to spend 2 weeks in the control room, live with a dispatch engineer. And the dispatch engineer had a TV set next to him. And the guy had the best job in the world. You know, he was watching all the soap operas, the Coronation Street, the EastEnders in UK. Those of you, some of you might know. And when that thing came, the guy was getting ready with his pencil to control the pumped storage. So as soon as the adverts hit the screen, he was just getting the pump storage generators to actually start spinning and generating, because he was trying to control the frequency. Could that be done by a machine? Yes, I'm 100% sure that it can be done. But that's how it was. And hopefully we'll move away from that.
I think we're keen to try and get a little bit of interactivity. I won't wait right until the end. We're about an hour in. So is there any questions from the audience at this stage? Yeah, have we got a roaming mic here, people, that we can... unless you... Oh, thank you. Testing.
Really good discussion so far. Steve J from Transpower here. Hey, there's many parts to our industry, and I see that everyone's going off and doing their own bit. So how do we collaborate more to get a better solution?
Great question.
Yeah, look, I think when we've sort of had discussions with across the industry, across the supply chain around different things which are you can only actually operate once. Load control is a classic example. We've brought the parties in to talk about that. The best way of actually getting to a solution and collaborating is just put the customer's shoes on the table and put yourself in those and work out what the outcome is. And that seems to be a common thing amongst everyone, is we talk about everything we're doing, but at the end of the day, if the customer's uninterested in it, they won't pick up the service. So that's kind of where we need to get to. And although at the moment, pricing a distribution network across to a customer goes through a retailer, and it's largely flat kilowatt hour charging, that's quickly going to change to cost-effective pricing, and that does need collaboration, but you've also got to bring in the policymakers to it, how that works as well. So it's you've got to really get around the table. I think Mark Gatlin summed it up beautifully last night when he talked about if you're having a discussion with someone and they're not getting it, then you're not actually communicating well enough, and that's where we probably need to pick the game up across the supply chain about better and more open communication.
Yep, go ahead. I'll get you to pass the...
Lewis here. I'd like to pick up on what Greg and Andrew were mentioning. I think the biggest disruption in our immediate future are social. I think the social climate is not favourable at present, as is reflected by, obviously, I believe, the Trump vote and the Brexit vote, where society is suddenly rebelling against the status quo. And I believe that we have to keep our eye on this, and somehow we have to enable society. Yeah. I'm not trying to be facetious in any way, but the world population is going to approach 9 billion. We're going to have artificial intelligence, so all the work's going to be done by machines. What are these people going to do when they haven't got things to do, and you've got them disenfranchised, and they believe they are disenfranchised? That's the formula for anarchy. Now, I'm not for a minute thinking that we're going to sort that, but I do believe that we as a social organisation or industry have a role to play. I don't know what that is. I'm just saying that we can't just look at the nuts and bolts and the bits and the bytes. We have to look at the people. That's my view. And I welcome any comment on that.
Yeah, I think you're right, Frank. I think there is a social license we actually all operate under, and we've got to keep reminding ourselves of that sometimes. So sometimes when you're actually thinking about what the next technology is going to be, we're very quick as Kiwis, number 8, why? If it's going to work, we've got to do it ourselves, right? So let's do this. But you can actually give away quite a bit of the technology to other people and let them help, a bit like the chessboard, just exponentially get it into the community so they come back and tell you they want more of it. Ideas we've toyed with around youth is they're right into gaming, they're right into all these things, very, very good at computing, and we would expect that there must be a way of tying that together at the high school level, of actually setting up some drone schools, setting up people who are very good at computers, very good at actually very quick responses, data analytics, and 200 people in your community, each with a drone that you supply and a very high digital camera and a license from Civil Aviation to actually bring back information about what my network looks like. And they can fly, they can adopt an 11 kV overhead feeder. We can give it a name if they want it. But what's more important for me is actually the community helping me understand what my assets are doing in real time. Affected communities with outages around trees, if we can actually get drones flying by the communities and bring information back, it kind of gets a bit more buy-in from the community rather than waiting for the a line truck or trimming gang to turn up and trim the trees. So those sorts of things we think the community can help us with. It's an employment thing. It's probably where younger people are going to go to. They're probably going to have a number of jobs rather than just one job for the next 40 years, like Frank with his gold card.
You've been talking about a couple of technologies, wind and solar, that are unlike the successful technologies you've talked about, motor cars and smartphones. They succeeded because they offered huge advantages and lower cost and things that didn't exist before. Wind and solar exist because governments have been misled into believing they're a cheap way of reducing carbon dioxide, and they're heavily subsidized. And according to Professor Michael Kelly, Cambridge University, the resource intensity of them is so great that present technology cannot compete against existing technology, conventional. But there are a couple of disruptive technologies coming up that you haven't mentioned. First is small and modular nuclear reactors. If you can have at every grid substation 200 or 300 megawatts of small nuclear reactors, as many as you need, and when they get tired, you ship them out and ship a new one in, what's going to do to your business? The other disruptive technology, I think, is DC. High voltage DC. New Zealand was the pioneer in the first big DC link in the world, part maybe from the Russians. But it's getting better and cheaper. And I have a personal sort of bet on that if the 400 kV line is ever used as it was meant to, it'll be energized with DC. And that's going to come down and down and down, and it's going to change our world. And it's a technology which is cheap, successful, and we know it's viable. These are what you should be thinking about.
Thanks, Brian. Unexpected question from you, I might add. Does anyone want to respond to that? I have to admit, in my research on exponentials, I haven't seen the price performance in nuclear following an exponential price path. But Edwina, what are your thoughts?
I want to add up. I didn't have a chance to actually put my bet on disruption technology. I kind of agree with Brian, because I think that power electronics is going to play a major role in the future, like transistor did in 1948 when it was invented and changed everything. And now in power system it is going to be power electronics. And we are getting faster and getting much better in producing semiconductor switches that are applicable in our industry. And the moment we start implementing them on a wider scale, it is going to make a huge change. It is already doing it with HVDC, with fax devices, with actually renewables, which when you look at inside, it's actually inverter behind, right? It is going to be power electronics. The only problem is the fact that at this point, that industry is moving very fast, and our industry, the way it is, it's kind of slow in a way, right? You have a transformer that lasts for 40, 50 years, even more than that. And then you introduce power electronics that control board can become obsolete after 10 years or so, and you have to replace it. And when you go back to look for the spare parts, then you realize there are no spare parts. You have to actually start almost from scratch. So the moment we solve that, that is going to actually impact our industry. So it is, in a way, DC as well, as you mentioned.
You're right with the power electronics. We've got that right now. We've got numbers of SVCs, numbers of StatComs scattered across the country. We've got the DC. The biggest trouble is trying to manage that on a 25-year life. We have to go in and replace everything, and it's almost 2/3 the cost of getting a new one. But that's power electronics. Yep, Cool. Your other questions about energy source, Brian? It's just kilowatts. It's just kilowatts. You just need to look at New Zealand as an energy balance, right? So we got so many kilowatts required from electricity now. We'll have so many kilowatts of energy required for transport or industry or whatever in the future. Where that comes from, I'd refer back to my previous point. It's a social issue. Regardless of what I personally think, it's what the bulk of New Zealanders think. And if the bulk of New Zealanders want solar panels and wind turbines, and the bulk of New Zealanders want something else, then that's what will happen. If other people want something else, then other people better go and organise it. But it's just energy.
I wasn't only talking about New Zealand.
That's fine.
I work internationally.
Brian, I
And
think there was
these other people.
I think there was another question just along from you, Julian.
Hi, so my thought on question one, what industry are we really in, is the industry of convenience. The main thing that electricity brings people is convenience, whether it's lighting in the home, having your appliances, having tools to do our jobs faster and better. But when we think about how the household is changing in terms of having batteries and solar panels and running your own side business, gig, selling your stuff back to Transpower, that sounds a lot less convenient. So that doesn't really add up to me. And so running all those services sounds like a lot of work. We'd all have to become our own asset managers of our own energy systems. It sounds like a lot more work. So what would you do? You'd outsource that to another provider, and they'd be the one making the profit out of it other than you. So really it's hard to see the system being more convenient for the user than it is now. As I flick on the light bulb and my supplier just takes money straight out of my bank account. I do nothing. So comments, do you think the future is going to be more convenient?
It's a good question. So why would I do it? Yeah. Andrew, I know you have a response to this because I heard you talking about it the other night, but Zia, would you like to...
No, I think I said you have a job as a consultant to go and advise her what to do. But just wanted to make a comment really to Brian. When you talk about the subsidy of the wind and solar, you're only thinking about the first world really. You're thinking about the developed countries. I think you need to look at the African states where they have any scarce energy at all. So introducing solar there is much easier, much cheaper compared to nuclear. You may disagree. Yeah, you may disagree.
What they need, because they can't contain anything, is nuclear reactors that they can put in and they'll just run.
And then they can blow it also.
But then you can replace them. And you can do a factory exchange. It's an absolute, ultimate, reliable, simple system. Nuclear power stations are not complicated.
I'm not going to go into the argument.
No,
Thanks,
I
Brian.
have to disagree. I'm sorry, I have to disagree. When you look at Africa and the way that is going to grow in terms of electricity is going to be actually for smaller, solar communities to larger ones, simply because, let's stop there, policymakers are very important there. So I don't see, in a political climate that the way it is going to be changed and implemented differently.
Can I
That's
just...
reality.
Sorry
I just
to
wanted
interrupt.
to tie that to the question from Stephen J. really, where how do we cooperate? I think in SEGRE we are trying to look at how we can help Africa and bring electricity to those countries because they have been left on their own, effectively. And nuclear power.
That's what I've been fighting for 40 years.
Can I just bring things back to New Zealand for a bit? It's a really interesting conversation, but just focus for a little bit on quite a different, but probably, certainly for many of us, more familiar form of disruption. And I think, Greg, you're really interested in your views on this, but we live on a quaky interface between two large masses of ground, and I think, look, the question is, resilience, major disaster events. We learnt a lot in 2011 in Christchurch. Quite a different form of disruption, but how do you see this fitting into this conversation around technology and change and our customers? What are your thoughts, Greg?
Yeah, look, I think technology has a part to play in making things a wee bit easier for fast response. And I think what we found in the November earthquakes was we came across certain situations we hadn't really thought our way through, and that's really around large buildings that fail structurally, and but there's still assets in their basement that are supplying the rest of the neighbourhood. So is it safe? Is it not safe to actually enter that building post quake to actually return supply? One thing we've found, which is it's common, it's around most sites in New Zealand now, is to take ground accelerometers and put them into buildings, and therefore you've got a very instant recognition of what that building has gone through, and from its rating and from the information you get from the accelerometer, you can make a very quick decision whether you're going to let people go in that building or keep them out and just shut the supply down and find another way of sorting that community out. That's a lot simpler than trying to find land or structural engineers to make assessments of buildings before someone can go into them, because that naturally means the structural engineer is going to be in the building. So post a quake, which is rife, as Peter will know, for when the next aftershock might occur. So there's some technology there which is really about just dispersed sensors, so you can actually make decisions around your assets or around other people's assets that you have your equipment inside. So something that local city council's done, and something that we'll be putting into our substations. We've got around 600 buildings, 320 of those are not ours that have substations in them, so we just need a quick way of making sure we can do our own rapid assessment electronically, and then basically from a health and safety point of view preclude people from going into buildings we know haven't been highly rated or are yet to be reinforced, and buildings that we can go in with the probability that there'll be less harm coming to our communities.
Thanks for that, Greg. Certainly one of the, I had a conversation with one of the people involved with the Christchurch sequence a few years ago, and the question that was put to me, is it better to tell your customer that you're going to reconnect in 3 hours and then fail to deliver and connect it in 2 days, or to tell them it's going to be 7 days, but to deliver on that promise? And it's a really interesting question around communication, tying together society as well, and ultimately the relationship with customers. Yeah, Graham.
Just a tiny little snippet to add to that, and it shows the power of data, social media, modern technology. National Grids in the UK, I think they spent about £2,000, 5,000 New Zealand dollars, and they mashed up Twitter feeds with filters for their control room. So as well as the dotted lines to show up when the adverts were coming, they had another screen, and they were able to filter through postcodes for substations, anything that mentioned substation, anything that mentioned electricity, and the kind of situational awareness and pre-response information that gave them is absolutely fantastic. I can't remember the estimates of the savings and speed of response, and actually avoided incidents in the power system as well, just through something as simple as, which my son could do, filtering some feeds on Twitter. Absolutely brilliant.
Yeah. While we're with you, Graham, I want to just change direction a little bit. Some discussion came up before about, I think from you, Edwina, initially, about how we've done things the way we've done them for many years, and we almost have this continuation bias about what's required, in our industry to do our jobs and protect the assets and people and so forth. But the question, Graham, is, what does it take to? You work with a company that sort of seems to have successfully broken that mold of getting an innovation, getting it out of the petri dish and commercialising it. What kind of mindset change does it take to achieve that success, in your experience?
Bloody mindedness. I think the challenges are vast, actually. The industry, for all the right reasons, codifies, standardises, creates longevity in thinking. You know, we plan for the long term, which is absolutely right. I think when we're looking at disruptive technologies as we are, the only issue with that is the speed of response to things that are externals to us. They're coming at us anyway. Electric vehicles, for example. Information technology is an example. And I think with 5-year, or in the UK now, bizarrely, move from 5-year to 8-year regulatory price control periods. 5-year, 10-year, 20-year planning statements. That doesn't lend itself well to fast response. And I think some of our biggest challenges are that, the planning cycle, the adoption cycle, the technology cycle. So while innovation and trials are incentivized, the quickly turning that into something that delivers value for customers and businesses is usually quite a lot slower. And, that's one of our uphill challenges just now.
Excellent. Yeah, Edwina. Sorry. So where you go? First in best dress.
Just a small observation. Maybe a decade ago, when you would go to the T&D show, you would see a handful of big companies exhibiting, right? That would be Siemens, at the time ABB, and a number of others, right? And even when you go now here in this exhibition, you see that actually there are small companies are emerging, entrepreneurial companies are emerging, and it is really good to see them, because ultimately I think they're going to change the industry the way it was, and it still is. And when we include the young people who are really digital from the moment they were born, right? That is going to be a big change.
No, it's a great comment, and there's also I agree with you about the presence at a trade show like this, but there's also that question in my mind about where are the big ICT players as well, and if they decide to take an interest in our industry, what does that mean for us? So far, it doesn't seem like they have. They've been the odd foray in, but really interesting question. Zia, sorry, you had a comment as well.
I was just going to add something to what Graham was saying, really. It took us in UK about 30 years to introduce serious compensation.
Right.
So the mindset that it takes you from that to actually, okay, let's do it, 30 years is quite a long time.
I guess, and it's not the only example, is it? I mean, it's the 61850 PMUs.
Pretty well.
Yeah.
We've been seeing some of the key people in the UK and how difficult it is to actually introduce something to people.
All right, thanks, guys. Well, by my timing, we've got about 6 or 7 minutes until 3:30, when I think the session's supposed to come to an end. So we'll go back to the audience. It was really good to have a bit of discussion there before. Are there any other questions for the panel, comments?
Yeah, thank you, Peter. I've just been reflecting on this question about collaboration, how we work a lot closer together. 29 line companies, and in the context of kind of what's going to initiate disruption, while your second point's about industry, what industry might initiate that disruption, I think it might be government, and I suppose I'm interested as to how close do we think we are in terms of government actually initiating the disruption necessary to force us to be a lot more collaborative, come together, standardisation. So I think that's something we need to be thinking about, but I'm also interested in terms of international experience. At what point in time have you experienced kind of government kind of initiating some disruption to kind of force closer working relationships, mergers, if you like, rationalisation?
I am aware, like European Commission is actually subsidizing a lot of research in this area, and I know one project, for example, which is relevant to the modern power systems, looking at the stability with the penetration of power electronics. It's called Migrate, I think. Graham, you might have heard about it. There's a lot of TSOs in Europe that are involved, and a lot of universities, and the money is coming from the European Commission. So it's initiated by European Commission, so which is a good example, and certainly that I can't see why it can't be replicated in New Zealand or Australia. to put the necessary funds together so that the utilities together with the universities can come and solve the problem.
Good one.
Yeah, in terms of the collaboration, you mentioned the number of companies. I don't want to step unerringly into an ongoing discussion in New Zealand in any way. I think that's probably the number of participants is a lesser factor than other things. I think in the UK we've got 14 license areas owned by 6 companies. There's all sorts of other reasons why they do collaborate well and then often don't collaborate well. There's all sorts of other reasons than that for why governance processes for standard and code changes can happen fast in some instances and then are interminable in other cases. So I don't think it's a matter of the number, much more about mindset, appropriate and streamlined process for the thing in question. Like Zia was mentioning there, to introduce one thing like series compensation to take so long, I'm not sure. I mean, I'm sure it's probably between the grid companies who wanted to introduce something like series compensation, so a great grid benefit, and maybe some of the generators fearing myth, urban legend about the damage to their equipment. We have to cut through that sort of spurious objection and call it out for what it is and get past it and get moving quicker.
Thanks. I think we've got time for another couple of questions. One in the middle here.
Just regarding sort of the prosumer and how that progresses, how do you anticipate blockchain technologies moving into the electricity industry and, I suppose, disrupting what we do?
Blockchain?
Yeah.
You want to go at answering that one?
Yeah, blockchain's probably more of a threat to the banking industry than the electricity industry, but it doesn't mean to say it won't happen here as well. I think the idea of people having some energy that they want to provide to someone else is important. The thing that around blockchain that is the detail is around keeping that ledger of the parties that are involved in the transaction. So you may have a solar panel where you want to actually transact that energy, so it'll go through your export part of your meter. So you'll change out your smart meter and put it in a 4-quadrant meter, then it'll enter a network somewhere. Depending on where reconciliation is going to occur, it could occur at Andrew's gateway, and then it may come back through another part of the network, which is another line in the ledger, which then has to go to the customer, who then will try and differentiate how the retail party at that transaction point will decide which is their energy and which is your energy. So it is difficult. I think in the US, and Edwina might be able to comment, we've got a bit more vertical integration between retail and lines companies. It's a wee bit easier. So that Brooklyn example makes it kind of flow, because you haven't got all the different counterparties. You've kind of got one party and the people with the solar. So the transaction's a bit more seamless. The ledgers aren't as long. So that's the downside of disaggregating an industry. I was just going to quickly answer Bob's question about consolidation. I think we're starting to see it in city councils with water bodies. We've got 5 water companies in Wellington. They've formed a group above that. It doesn't mean it's amalgamation, it just means that some of the services are provided by one provider across 5 service layers. So I think that'll start to happen around collaboration in our industry. We run a very large SCADA system. There's plenty of room to actually help others with providing services off that as well, so that may happen in the future at some other stage.
Guys, I think we've got time for
on your,
probably one more.
Blockchain item. Remember, that's just a ledger, that's just a way of keeping track. Because you think of all the other services that you already use today, where there are multiple service agents using multiple networks to deliver you the service you want. And you just need to think of using your cell phone today to call your mother-in-law in Germany or someplace like that. There is multiple telecommunications companies who you are passing through, and they all get paid, and all the networks in place. Electricity is not really that much different, right? So looking into other industries, be it the financial sector, telecommunications, or somebody else for some of these things, is really it. Blockchain is just a way of keeping track of where the ledger of the number is.
Guys, we're just about on time. I think I need to finish at 3:30. What I'm going to do is just let Graham quickly respond, and then if we've got one quick question, then we'll take it. So
yeah, and just in blockchain, I think where you have an organised market, you have organisations of trust and authority to do the ledgering. You don't necessarily need that. I think where you're not organising a market, and that might be the case in transactive energy or maybe other services that come along, then blockchain comes to the fore because it's a public, it's a platform of trust, effectively a ledger system of trust, and that allows individuals out with an organised market to have trust in the record keeping, and I think that's probably where it'll find its application.
Thanks. Just last question in the front here. Thank you.
Robert Barr, Electric Energy Society of Australia. Just a quick comment on item 2 of industry disruption. I'm fascinated by industry disruption, and I've got a little example. I travel a lot and used to use taxis, and then my children introduced me to Uber, and I suddenly find with this technological disruption that I've got this new service and it's fabulous. You know, it's no cash, and the taxi, it comes to me, and what's really unique about it is that it provides a service that can actually wipe out the taxi industry. Uber, I'm sure, can just replace taxis. It's a very simple process. Now, I come to Eastern Australia, where the power industry is running, and as you probably will know, there's a lot of baseload coal, big, slow, heavy, and it's going along quite nicely. The big disruptor becomes the intermittent renewables, wind and solar on a very large scale. And South Australia is like the canary of not just Australia, but the world, you know, where there's enough wind generation there on a good day to supply the whole state and still export a little bit to Victoria. But the disruptor there is that the baseload generators that are big, slow and heavy can't cope with the variation of the output of the wind farm. So when it's windy, they've got to back right off. And when it's not windy, they've got to produce. And so these machines that were not designed to do the ups and downs are suddenly got to do the ups and downs. And so over time, these baseload power stations go broke. They're closing down. And but what's interesting is it's a disruptor that can't replace the thing that it destroys. And this is where the very, very high cost comes. And maybe you're a bit fortunate here in New Zealand because a lot of your generation's hydro, and it's got the flexibility that our baseload coal stations doesn't have. But business disruption can be very disruptive, more disruptive than just replacing the thing, actually destroying it and then not being able to replace it.
That's right. So it's a good comment, you know, and the examples like Kodak and many others are testament to that, aren't they? Look, great conversation. I would love to be able to keep it going for another half an hour or so, but I'm afraid we do have to end there. So thank you very much, audience, for your participation and attention, but mostly thank you to our panel. Please join me in a round of applause.